Okay, hello everyone. I am Om Ghodgi and today I'll be solving lab 5. So the first question was hollow diamonds. You are given an integer n and you have to print out this hollow diamond pattern. Okay, so when you see this pattern for the first time, there are a few things that you should notice directly. Um, so the spaces on each line, that's the first thing to notice because the stars are easy to calculate. The first and the last line only has one star, and all the other lines will have two stars each. And then the gaps. So the first line has 1, 2, 3 gaps over here. The second line has 2 gaps. The third line has 1 gap. And then this has 0 gaps. Then this has 1 gap again. This has 2 gaps. This has 3 gaps. I'm not talking about the hollow part inside, I'm just talking about the outer part over here. Similarly, on this side, the outer part has 1, 2, 3, 4, 5. So this has 5 gaps over here. This has 4 gaps. 3, 2, 1, 0, 1, 2, 3, 4, 5. Okay. Um, so in order to get these gaps right, you could have a loop which runs from, let's say, this is 3. So you can have a loop that runs from -3 to 3, and then you can take the absolute value of the number and print out the gaps. I hope that makes sense. If you have a loop that runs from -3 to 3, then you'll have 3, the absolute values as 3, 2, 1, 0, 1, 2, 3. Similarly, over here, if you have a loop that runs from -5 to 5, and you take the absolute value for the spaces, so you'll have the right spaces. You'll get 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. So this will give you the outer spaces correctly. In order to print a single star on the first and the last line, you can just check that if the absolute value of the counter, or I, let's say, is equal to 3, then you just print 1 star. Similarly, over here, if the counter value is equal to 5, then you just print 1 star. Okay, so that is the stars done. Now we need to talk about the internal gap. So over here on line 2, you have a gap of 1 star. Then this has a gap of 3 spaces. This has 5 spaces. Then this has 3 spaces. This has 1 space. Okay, so before I tell the inside part, 3 over here is the same as 7 by 2. If you do integer division, 7 by 2 will give you 3. Similarly, over here, if you do 11 by 2, it will give you 5. So this loop simply runs from -n by 2 to n by 2. For the inner part, okay, if you have n by 2, in this case n by 2, for n equals 7, n by 2 is equal to 3. Okay, so let's say that our loop is running from -n by 2 to n by 2. So we want 0 gaps for -3. I'll just copy this. We want 1 gap for -2. We want 3 gaps for -1. We want 1, 3, 5 gaps for 0, and then again we want 3 gaps for 1 gap for 2, and 0 gaps for 3. Okay, so again you can see there is some pattern which is following the absolute value. The absolute value of this number determines how much gap there will be over here. If you do a similar analysis for this, you will have for n equals 11, you'll see we want 0 gaps for, okay, let me copy this, for -5, 1 gap for -4, 3 gaps for -3, 5 gaps for -2, 7 gaps for -1, and did I do this right? Okay, yeah, 9 gaps for 0, and then 7, 5, 3, 4, and 5. So this the absolute value of the counter is determining how many gaps there will be in the inside. So the formula, you can see it from here, maybe from observation, that when the counter is 0 you have 5 gaps, and 5 is the same as n minus 2 over here. Or you could think of it as n by 2 plus whatever. Okay, so the formula for this would be n by 2 minus absolute value of I. This will give you, okay, so let's take an example, 3. So we have this as 3 and this is 3, so it gives you 0. Then you have this as 3 and this as 2, this gives you 1. And then this doesn't work out. If you see, this is 1. If you put 3 minus 1, you get 2, but you wanted 3 over here. So okay, let me write this as well. This equals 0, this equals 1, this equals 2, this equals 3, 2 again, 1. Okay, so 1 should map to 1, 2 should map to 3, and 3 should map to 5. So essentially these are just odd numbers, and you can do this easily by doing 2 into n by 2 minus abs I plus minus 1. So let's take this example over. Okay, let's take this example over here. This number is 1, so if you plug it over here, 2 into 1 is 2, and minus 1 gives you 1. Then for 2 you'll have 4 minus 1 3, for 3 you'll have 6 minus 1 5, and this will give you the right value for the inner part each time. Similarly, you can do this analysis for these numbers as well, and this formula will give you the right numbers, the right gap for each of them. So this is the amount of gap that will be on the inside, and the amount of gap on the outside is just absolute value of I. So that's how you will write the whole code. Now I'll proceed to write the code itself. Okay, include simple CPP. First you take n as input, then for int I equals minus n by 2, I less than equal to n by 2, I plus plus. Okay, int abs I is equal to absolute value of I. If you don't want to use this, then you can also do this, I less than 0 question mark I into minus 1 as I. Even this works, whatever you are comfortable with. And then you write for int j equals 0, j less than abs I, j plus plus, cout space if abs I equals n by 2, cout star So um, this initial part prints out the outer spaces. So these spaces are being printed by this loop. Of the this is the case for checking if it's the first or the last line. So if app size is equal to n by 2, then you just print a single star and do a new line. Else you print a star, and then for int j equals 0, j less than 2 into n by 2 minus app psi minus 1 j plus plus c out. So this prints the first star on each line. Then you print the right amount of gaps that are there in between here for each line, as we saw this formula before. Oops. And then we print the final star and do a new line. Okay, that's it, I guess. Prints inner spaces of the diamond. Okay, that's enough, I guess. S plus plus. So if I put 5 over here, we get the right our pattern. If we put 7, 3, 11. Okay, yep, that was it for this question. Yeah, let me add this. Alright, yep, that was it for this question. Okay, now on to the second question. Over here you are given two rectangles, and you have to calculate the intersecting area of these. So you are given x1, y1, x2, y2, x3, y3, x4, y4, and you need to find you need to write a function that will return the intersected area of the rectangles. Okay, so I will start off with writing the main function so that you get an idea of how the function call will happen. Simple cpp. Okay, I'll start using int main now. Is int x1, y1, x2, y2, x3, y3, x4, y4, and then x1, y1, x2, y2, x3, y3, x4, y4, and then get area, all of these. And you do C out. So this will be your main function, and int get area, int x1, int y1, int x2, int y2, int x3, int y3, int x4, int y4. So since you have learned references as well, I'll take all of these as references over here. There are too many variables, so instead of copying them, I'll just pass them by reference. Okay, so what will this do? Okay, so let's say you have two rectangles, rectangle 1, rectangle 2, and you have x1 y1 here, and x2 y2 here, and x3 y3, x4 y4. Okay, now what you have to do is find this shaded region, this area here. Let's call this point and this point as xu, which means the upper coordinates, and let's call this as xl, yl, the lower coordinates of the intersecting rectangle. Okay, so you can also have a case where this guy is over here, in which case these points will be over here, but we will still calculate this point and this point from here. Okay, so yeah, but for now let's just let's keep it here for now. Okay, so to find this coordinate here, it will just be xu will simply be the maximum of x3 and x1. So if x1 is placed here, then this coordinate will be x1. So whichever is the maximum of x1 and x3, that will be xu. Similarly, yu will be the minimum of y1 and y3. So right now y3 is over here, but you can have a case where you have y1 as the smaller guy. So over here y1 will be smaller than y3, so yu will be equal to y1 here. Okay, so xu is the max of x1 and x3. I'll just write it down over here. x1 equals max, oh my bad, xu equals max x1 x3, and yu equals min y1 y3. Okay, similar to this for xl and yl, xl will simply be the min of x2 x4, and yl will be the max of y2 y4. Make sure you understand this properly. So x2 is here and x4 is here, that's why xl will be equal to x2 for now. But if you move it like this over here, now this point over here, this point has the coordinates x4, so xl will be equal to x4 here. And similarly, if you have since y2 is bigger than y4 here, that's why yl is equal to y2. But if you shift this down, this is fine. If you shift this down, then this coordinate over here will be y4, so yl will be equal to y4. So whichever is bigger between y2 and y4, that will be equal to yl. Okay, so that will give you xu, yu, xl, yl. Now once you've gotten these, you have to find a case where there is no intersection at all. So let's say this case over here, there is no intersection over here. So what will your xl, yl, xu, yu return you here? if you follow these formulae, I'll just hide this. Alright, if you just follow these formulae, your xu will be the max of x1 and x3, so, and yu will be the min of y1 and y3. So your xu yu will be this point and your xl yl will be this point. And you can simply check that xl should be bigger than xu. So if xl minus xu is less than 0, or yu should always be bigger than yl. If you have yu minus yl to be less than 0, this means that there is no overlap, so you will return 0 from your function. Otherwise you will return xl minus xu multiplied by yu minus yl. This will be the area of your rectangle. Okay, so yeah, this is the whole code for your function. So let me write it down here. Int xu yu xl yl. Okay, if you don't want to use the max function, then you can just you can just start them off with x1, yu will be y1, xl will be x2, and yl will be y2. Then you can simply write if xu is less than x3, then you do xu equals x3. This is the same as taking the max between x1 and x3. So I have indirectly compared x1 and x3 here, and if this is true, then I've set xu to x3. I can actually do this as well, it's the same thing. Okay, then if y3 is bigger than y1, if y3 is smaller than y1 is bigger than y3, then you set yu equals y3. Over here you have to take the min. So if x2 is bigger than x4, you will set xl to x4. If y2 is less than y4, you will set yl to y4. Okay, if y4 is if y4 is bigger, then you will set yl to y4. Okay, now you write if xl minus xu less than 0, or yu minus yl less than 0, you will return a 0, else you will return this. Okay, s plus plus 2 rectangles and okay, let's try. Okay, this works. Okay, alright, ठीक है, this code works. I will just add some comments. Checking for no overlap condition, finding the coordinates coordinates of the intersecting rectangle. Okay, that was it for this question. Okay, now onto the calculator question. So you have to make a function called calculator. So I'll start coding this up directly. There's not much explaining to do in this question, just practice writing code, practice writing functions. Um, oops. That accepts three arguments and based on the character returns the result in the main function. So you'll return an integer because there are only integers used over here. Yep, the input are all integers and the mathematical operators. Okay, so you'll have a function called calculator, takes in three arguments, two integers, int a, int b, and one character, char op. Okay, then what you do is you write a switch case on op directly, and the first case is plus, in which case you can return a plus b, case star, return a star b, case minus, return a minus b. For division, have they told? Okay, they have told that no invalid operations will be performed. So case return a by b. Yep, that's it. And if you have a default case, you could say argument and then just return from here. Okay, then this is your calculator function. Okay, so your main program, int main, what will this do? It will accept an integer from the user. So let's call this num, and then followed by a mathematical operator and followed by an integer. So I'll create a character op and then I'll take cn op, while op not equal to x, num2. Okay, let me create num2. So and then I will call the calculator with num and num2 and op and store this inside num, and then I'll do cn op again. Get the result and store it, accept another mathematical operator and an integer. Okay, and then at the end you will print out num. Let's see if it works. Oops, non-void should return a value. Okay, return -1. This case will never happen, so you can return anything over here. Okay, let me put this -30. Okay, that's right. -1980 -25. Okay, and I'll try this one as well. Okay, alright, so I'll explain the code a little now. So I think the calculator function is pretty simple. Whenever I encounter a particular operator, I just return that value from here, and this will never happen, so you don't have to worry about this case. Over here, the reason why I have taken one cn of op outside and another inside is because I need to check for this. whether op is not equal to x. So another thing you can do is just do this inside and write if op equal to x, just break, and then you can put a true here. This is another way of writing the same thing that I had written. Okay, so I'll explain what I had written. Okay, so first you take in an operator and then you check whether this operator was x or not. If it was not x, then you take the number in, and after you've done the calculation, then I am putting the op over here. So I pulled one cin outside of the loop over here and put one over here so that I don't. Okay, the problem that will happen is if I put this here and remove this, and let's say that the user, okay, what happened? Yep. Okay, so you cannot write this because it is uninitialized. So yep, you'll have to put this over here and then you will have to do this eventually. So if op equals x, then break. So this is the same as that, but this requires more lines than what I had written. That's all. Okay, so even this will work, but I prefer that. Anyways, so instead of storing this and returning this, a better way to solve this would be to make this void and pass a as reference, and then do a plus equals b and then return, and then the same for all lines. So this will just be a practice for you. Okay. Oops. All right. So if I were to do this now, okay, my bad. So you can remove this. Okay, now if I put this, you get the same answer. So this is with passing a as reference, and this works out. So yep, that was it for this question. Okay, moving on to the next question. Uno dos sort. So you are playing Uno with your friends and you have 4 cards remaining, and you want to sort those cards in ascending order so that you can evaluate what to play correctly. Okay, so given 4 integers, you have to sort the 4 numbers and print them in the sorted order. Write a function sort cards. So as in how you're reading the problem statement, you should start coding up small parts. So you will create a function sort cards which returns void. So you'll have void sort cards, and it takes in 4 integers passed by reference. So I can call them int and a, int and b, int and c, int and d, and sorts them in ascending order. If required, the sort cards use the swap function for swapping to integers. The inputs to swap function are passed by reference, which return void and swap the 2 integers. So we can create this function void swap int and a, int and b. So there is a cool way of doing sort with a swap, which is this. Yep, that's it. But you don't have to do this. You can simply do int temp equals a equals b equals temp. This and this is the same. Try and convince yourself why this works. So I'll keep this for now. Okay, so this is the swap function. And then okay, so the main function, it accepts an integer t, so you'll have int main cnt, and for each test case you take in 4 integers. So you'll have either a for or a while loop. I'll just write while t minus minus. This is the same as writing for int I equals 0, I less than t, I plus plus. Okay, you will create 4 integers b, c, d, and you will take them in. Okay, and then you call the sort card function directly. So you will just do sort cards a, b, c, d, and then you will print out a, b, oops, d. Okay, this is your main program. The final output for each test case should be printed from the main function only. Okay, so this is getting printed from here. Alright, to solve this question we will use a trivial version of the bubble sort algorithm. Okay, so this is where you need to understand what is going on. So there are 3 passes over here, and you are just swapping or consecutive elements. Okay, so I will clear this out. Okay, you have a, you have b, you have c, you have d. So in the first pass you check these two, you check these two, and you check these two, and let's say that a was bigger than b. If a is bigger than b, then you will swap these two guys. Then if b is bigger than c, then you will swap these two guys, and if c is bigger than d, then you will swap these two guys. So after one round of swapping, the biggest number amongst all these will be stored in d. Okay, make sure you understand this. Let me get rid of all of this. Okay, a, b, c, d. Okay, let's say that the biggest number was a for now. So we check that if a is bigger than b, then we swap it. So now b is the biggest number. Now we check b and c. Since b is the bigger number, we swap it again. Now we check c and d. Since c is the bigger number, we swap it. So the biggest value is now in d. Okay, what if we start from b? Since a is less than b, we don't do a swap over here, but it will follow the same thing from here. So b is bigger than c, so this will get swapped. Then c is bigger than d, then this will get swapped. So d will have the biggest value. If c had the biggest value, then there will be no swaps between a, b, b, c, but there will be one swap between c, d, and then the biggest value will again be in d. And if d is already the biggest value, then there will be no swaps required over here. D will already have the biggest value. So after 3 such swaps between a, b, b, c, and c, d, we say that d will have the biggest value. So this part is sorted. You don't have to deal with d anymore. Now you have to deal with a, b, c. So now what you do is you put the biggest value amongst these 3 into c, the same way you did it for d. Then you are done with sorting this part. Now you're left with these 2 numbers, and then you will swap these 2 numbers once more to get the bigger value amongst these inside b. And then finally a will get the smallest value, and then you have sorted the whole array, all the four numbers. Sorry, forget arrays for now. Yeah, so that is the whole bubble sort algorithm that is explained over here. After the first pass, D will contain the biggest number. After the second pass, C will contain the biggest number. After the third pass, B will contain the biggest number, and A will automatically get the smallest number from this algorithm. So if there are n numbers, you will require n minus 1 passes to get all the n minus 1 numbers, their particular number, and the last number will automatically get the smallest number. Okay, alright, that was what I had to explain. So now writing the code is easy. You already have the swap function. So your first pass will simply be if A bigger than B, swap AB. If B bigger than C, swap BC. If C bigger than D, swap CD. Now you do your second pass. If A bigger than B, swap AB. If B bigger than C, swap BC. And now finally the third pass. If A bigger than B, swap AB. Okay, and then you return from here, and that's it for this code. Okay, let's try out a test case. What have I gotten? 1729. Okay, 17912, 082356, and 1270 1299 1388. Okay. Let's try this one. 8790 534 45567, and finally this one. 198209. Okay, looks fine to me. 7687 5566 3489. Okay, fine. So that was it for this question. Okay, I think I should explain this swap function a little bit. Alright, so okay, so you have the first statement is A equals A XOR B, and the second statement is B equals A XOR B. So in the first statement you have made A as A XOR B now. So when you write A over here, you are essentially writing A XOR B here. Forget this for now. When you do A XOR B, you might know that if you take the XOR of two numbers, this becomes 0. So if you have, let's say, any number num XORed with num, this will give you 0. This is a property of the XOR. Why does it work? Okay, let's say that your num was 9, so 9 will be 8 plus 1 in binary. It will be 1001 in binary, and you might know that this is a bitwise XOR operator. So when you write 1001 over here and 1001, you will take the XOR bitwise for each of these. So 1 XOR 1 gives you 0, 0 XOR 0 gives you 0, 0 XOR 0 gives you 0, 1 XOR 1 gives you 0. So the thing is that if you take the same number twice, all the bits at each position will be the same, and same bits have an XOR of 0. Only opposite bits have an XOR of 1. That's why when you take any number and you XOR it with itself, you will get the same number. So this over here, when you do this, B XOR B is nothing but 0, and so you are taking the XOR of A with 0. Okay, so now this will give you 1001, because you can write this as 0000, and the XOR of any number with 0 gives you the number itself. This is another property of XOR that you should know. And if you have all ones over here, then all these bits will get flipped, so you'll get 0 1 1 0. Okay, so one flips a bit and 0 keeps the bit as the same. These are two things that you should remember. Okay, so A XOR 0 will give you A over here. Alright, and then after this, what you've written is A equals A XOR B. This was the last step, right? And before it was written A equals A XOR A XOR B. So remember that this A over here is actually this A. So this is A XOR B here, and B is now equal to A. So this is nothing but A here. Okay. So now if you do this, now you see there is A XOR A. So okay, you can actually move this thing around. This is something else that I didn't say. You can actually write this. The XOR operation is commutative. I think that's the right, or associative. I don't remember. Wait. The XOR operation is commutative, so you can write this, and then A XOR A will give you nothing but 0, and then taking the XOR of B with 0 will simply give you B. So that is why this works as a swap function, and this is more memory efficient, and it might be computationally more expensive, but it is memory efficient. So is it memory efficient? You will require a temporary variable to store these values, so it might not even be memory efficient. Okay, yeah, so you could actually do this, but yeah, that is a cool way of solving it. That's all. Okay, that was it for this question. Okay, so the next question was shelf sorting, and this question is very similar to the question I solved right now. The only difference in these two questions is that we have characters instead of integers. So what I will simply do is just where else? Here. I'll just make these as characters, and I will change the function name. So the function name is sort books now. Okay, wait. A equals B, B equals temp. Touch shelves. Okay, my bad, I didn't have to do that. Okay, now I can modify this. I think this should work, and then I make this as sort books and this as sort books. Okay. Alright. Let's try this out. S++ shelf sorting, and where are the test cases? Okay, IJKL STUV. Over here you don't require spaces, so I can get rid of these. MNOP ABXY EFGH. Okay, yep, this works. So it's the same but with characters. That's all for this question. Okay, now for count number of ones. Alright, I actually have. Okay, so given an integer, you just need to find the number of ones in its binary notation. Okay, so there is this built-in function which is there inside simple CVP, you could say for now, which is called built-in pop count with 2 underscores, and you just pass the number in and it will print you the answer. So this is the answer for this question. That's all. Count ones and A dot out. Let's try this number, and it gives you 13 as required. Okay, but this was not expected of you, like you knowing that this function exists. So I'm just telling you for so that you know now. Okay. So you can use this if you are in a hurry to solve some questions. 14th Feb 25. Okay. So the ideal way to do this now is to write is to check bit by bit if a particular bit is 1 or not. Okay, so let's just take this example. You have this bit, this number. Okay. You might know that when you divide this number by 2, you will get rid of the last bit. So, and when you take the AND of this number with 1, you get the last bit. I hope these two things are clear, that when you do AND 1, you get the last bit, and when you do by 2, or when you do right shift of 1, you get rid of last bit. Okay, left shift of 1, right shift of 1, sorry, right shift of 1 is the same as divide by 2. You will just shift all these bits to the right and get rid of this last bit. You just throw it away. So this will be your answer after you right shift it. Okay, alright, so these are the two things that you need to understand to solve this question correctly. Okay, so now I write this while n is greater than 0, and after each iteration I will shift n to the right by 1. So what am I doing? This will simply be this number and removing the last bit. Then I will take this and shift it by 1 to get me this, and then I'll shift this by 1 and then I'll get this, and then I shift this by 1 to get this. I'll shift this by 1 to get this, and then I'll shift this by 1 to get 1 0, and then to get 1, Finally this will give me 0, and this is where your loop will terminate because you've reached 0, n has become 0. Okay, so in all of these, what do I do is I take the AND of this number with 1. This over here will give me 1, this over here will give me 0, this over here give me 0, this over here will give me 1. What I'm doing is I'm checking the last bit over here. When you take the AND of any number with 1, you get the last bit because everything else is 0, so everything else will become 0. If these two are 1s, you will get a 1. If this is 1, this is 0, you will get a 0. If this is 1 and this is 0, which will not happen because this is a 1. So yeah, whenever there is a 1 here, you will get a 1. Whenever there is a 0 here, you will get 0. That's why this gives you the last bit all the time. Okay, so this will give me 1, this will give me 0, and this will give me 1, this will give me 0. So now all you have to do is add all these numbers up. This will give you the number of ones that are there in your number, because you are extracting each bit one by one, and if it's a 0, it's a 0. If it's a 1, then you need to count them. So adding all these numbers up will give you your answer for this question. So you can create an int answer which starts from 0, and then you just do answer plus equals n and 1, and then you do cout answer. Yep, that's it for this question. And then you pick this number, 13, you pick this number, 4. Okay, 4. Yep, that was it for this question. Extract the last bit of the number and add it in sum. Get rid of the last bit of the number. Iterate over each bit of the number n. So nowhere in this program have I actually converted n to a binary number. It is still a decimal number, but the way I'm processing it is bitwise. That is the thing. That's something that you should understand. So that was all for this question. Okay, now on to Fanum Tax. So O must deep asleep, and you. Okay, so this is kind of outdated now. I made this question when the union budget meeting had happened, and it's been a long time. So anyways, so there is this new tax policy that a person with X years of experience and salary of Y, the X bit of Y determines whether they are taxed or not. So let us take an example here. Okay, let's say that your Y is so small. Okay, let's say your Y is 101110. Yep, this is good enough, and your X is equal to 3. So you have to check the third bit, so which is this. Since this is 1, this particular guy will be taxed, and after tax he'll be left with 10101 001. So this bit will become 0, and this is in binary. Y will not actually be this. Y will be 0 1 2 3 4 5. 2 raised to 5 is 32 plus 16, 8 plus 4 plus 1, which is 45. Okay, so your y is 45, and in binary it will be this. Alright, and then you have x is 3. So now you check the third bit of 45, which is 1, and after tax your number will be this, which means in decimal it will be 32 plus 8 plus 1, which is just 41. So okay, this is after taxing. Let's say your number did not have, okay, instead let's say you had 2, so 2 is already 0, so even after tax you will be left with 45. This is the question. If this particular bit is 0, there is no taxation, but if this bit is 1, then there is taxation, and that bit will become 0, and this is the money that he will have after tax. That is what you need to solve for. Okay, so how do you write code for this? How do you check the third bit in this case? Okay, so let's say you have 1 and you left shift 1 with 1, you will get 1 0. If you left shift 1 with 2, you will get 1 0 0. If you left shift 1 by x minus 1, you will get 1, and x minus 1 zeros. So because when you do 2 you get 2 zeros, when you do 1 you get 1 0, when you will do 0 you will just get 0 zeros, which means you will get 1. So in this case we have a 3, so 3 minus 1 will give you 2, so you will have 1 0 0. Okay, what do you do with this number? So you have 1 0 1 1 0 1, and you have 1 2. Okay, alright, forget this. Alright, so you have to check the third bit, right? This particular bit. So when you take the bitwise AND of these two numbers, these are zeros, everything else in front of this is zeros. So when you take the bitwise AND of these two numbers, all these zeros will give you zeros. These numbers don't matter at all, only the xth bit matters, because this is 1, so only the value of the xth bit over here matters. If this is a 1, then your answer to this will be 1 0 0. If this was a 0, then your answer would have been 0 for this, because 0 and 1 will give you a 0, and the rest are all already zeros. So your answer to this particular thing will be greater than 0 if and only if the xth bit in y is 1. Otherwise it will be 0. This is exactly what you want, right? You want to check whether the xth bit is 1 or not. So if the bitwise AND of this particular number, which is 1 left shifted with x minus 1, if you bitwise AND this with y, if this is if this is greater than 0, okay, if this is greater than 0, then the x bit is 1. Y will be taxed, otherwise y will not be taxed. Okay, this was the first part. You have found whether y will get taxed or not. Okay, so now how to find the money after taxation. Okay, so you have 101101 and you have this 100. So after taxation you have to make this bit to 0. So one thing you can do is just subtract these two numbers. Since these are all zeros, they will not affect this number at all, but since these both are ones, 1 minus 1 will give you 0. So you will exactly make that particular bit 0 and the rest of the numbers stay the same. Oops, yep, this. When you subtract these two, you'll get this. That is one way of taxing. The other thing that you can do is take an XOR over here. This is what I want you to understand. So when you take the bitwise XOR of this number with this number, all the 0 guys, they will not affect it. Whenever you have a 0 and you take the XOR of anything with 0, it will give you the same number. So all of these guys will return you the same bits that were here. Only when you XOR with 1, it will flip the bit. So if there was a 1 over here, it will make it a 0. If there was 0 over here, it will make it a 1. But you've already checked that this bit is 1. So you will never have the other case of this being 0 and it turning to 1. So you will never increase the money after taxation. You will always decrease it because this you have made sure that this is 1. So your code will be something like this. If y and 1 left shifted with x minus 1 greater than 0, y XOR equals 1 left shifted x minus 1 times, and then you will do a return true, and over here you'll do a return false. So this is your code for this particular question. You will check whether the xth bit is set or not. If it is set, then you apply the appropriate tax and then you return true. Otherwise this bit is set to 0 and then there will be no taxation and you just return false. Okay, so now let's have a look at the code. Alright, so I have made a variable called mask, which is just 1 left shifted with x minus 1, and then I check if y and mask equals to 0. I have written the other case. So if this is equal to 0, then I just return false. Otherwise I do the XOR of y with mask and then return true. I can also make this, and yep, this is your function, calculate net income. In your main program, what you'll do is you'll just have t test cases, and then you can either write a for loop or while t minus minus. You will take in x and y and you will call this function calculate net income. If this returns true, then this will be called, so this will be executed, so you'll print taxed. Otherwise you'll just print not taxed. These are also not required. Okay, and then okay, my bad, this was required over here. Yep, so you will print not tax and then print out y. That was it for this question. Yep, you didn't use bit shift and bitwise operators and avoided loops. That's what was required for this. Okay, now we move on to the next question, reversing a number using recursion. So you were just introduced to recursion, so I will take this question a little slowly. In recursion, you have the first thing, which is called a base case, and then an inductive recursive step. This is very similar to induction, which you might have learned in maths. You first have a base case and then you prove an inductive step. So recursion is something similar. You try to break down a problem into a sub problem of the same type. which you can solve using the same function itself. Okay, so that is what recursion is. So let's take this example 345 and you want to convert it to 543. So in your main program you have this variable called n, and you have a variable called rev. Rev is just the reverse of the number, and you input this number n from the user. You call this reverse function. There is a semicolon missing here. This reverse function will reverse n and store it in rev. Rev is passed by reference, so the value stored over here will be the reversed value, and then return 0 is not required. So after calling this function, it will do something and put the reverse number inside rev, and then you can print rev directly. So what does this function do? Okay, let's say that if n was 0, this is the base case of your recursion. If n is 0, your reverse is already 0, so you don't need to do anything at all, you just return. Okay, if it is not 0, if it is some value, so okay, 3 4 5. So in the first call to your function reverse, what you do is you set rev to 3 and then call reverse on 45. Okay, then in the second, okay wait, I'll write first call to reverse. This is what will happen. Then second call to reverse, you will have rev as 3 5 and then call reverse on 4, and then third call to reverse, rev will become 3 5 4, call reverse on 0, fourth call base case simply returns. And then when you reach here, this will return to here, then this will return to here, then this will return to here, and finally this will go to your main, and over here you will print rev. So this is how it works. So in each call, right, you multiply the rev value by 10 and you extract the last digit of n. Okay, so in each step, so let's say when you did this call to reverse, currently n is 45. So what you did, okay, I'll just write over here as well. Currently n is 345. Oh wait, did I start with 345? My bad, wait. Okay, I explained it incorrectly. This should be 5, this should be 3 4, this should be 5 4, this should be 3, and this should be 3 4, and then you'll have 5 4 3 0. Okay, sorry for that. Okay, this is correct now. So firstly your number is 345. you extract the last digit from here, you put it in rev, and you make this 34. Then you get 34 here, you extract the last number from here, 4, you multiply the existing number rev, which was 5, you multiply that by 10, and you add this number over here, which makes it 54, and then you remove this last number and you pass it on 3. And then similarly over here, currently n equals 3, so you will multiply rev, which is 54, with 10, and then you will add this number, and then you will remove this, and you're left with 0. So on the fourth call, you will get into this base case and just return without doing anything at all, and then you will return back to the main function. So that's all that is being done. You multiply rev by 10 and you add the last digit, and then you call reverse on every other digit but the last digit. So n by 10 will remove the last digit and call it on the rest of the digits. So that's it for this question. Yep. Okay, now on to the next question. Time to crib. Okay, you are attending the CS101 crib session and you need to check whether your total is right or not. So you will be given, okay, you have to write a function sum marks. So you start off hash include simple cpp. Okay, sum marks returns a double, so you'll have double sum marks int n. Containing the sum of n marks. So as you saw before, there are two steps in writing a recursive function. The first is the base case. So the base case over here will be if n is 0, then you return 0. Okay, if n is 0, there are no more numbers that you have to input. If n is not 0, then you will see an enum, and then you will return num plus sum marks. Okay, my bad, this should be a double, sum marks n minus 1. So what does this do is you input one number, and then you say that sum marks n minus 1 will give you the sum of the remaining n minus 1 numbers, and then you just add this one number to it. So this will give you the sum of the n numbers, and then you return this directly. So this base case will make sure that when you reach 0, it will return 0. We'll do a dry run of this so that you get an idea. And then your int main will be call the recursive function correctly. In the main program would call sum marks. Okay, so you have int n, and then you have a double total marks, you see an n and total marks. And then you call sum marks n times, and you store it sum. Then you write if, oh actually you could have done this directly, if total marks equals sum marks n, then cout total is correct. else cout time to crib. Okay. Let me see if it works or not. S plus plus total is correct. Time to grab total is correct. Okay, so let's do a dry run on this example. Okay, so you have these numbers. Alright, let's forget that these for now. You took these two and then you called some marks n 3. So now what will happen, this is your main. Okay, alright, so over here you'll have some marks, n is currently 3. So what will happen over here is you will see in a number which will be 1.1 in this case. So you'll just 1.1 and then you will do a return 1.1 plus some marks of 2. Okay, so when you call this function, this will make some marks here with n equals 2. Over here you will see in 2.5, so you'll get 2.5 here. Actually this is not the right way to write it, but I'm just demonstrating what's gonna happen. So you get 1.1 here, get 1.1 here. This is a better way of writing it. And then you do return 2.5 plus some marks of 1, and then this will call some marks with n equals 1. You get 0.4 here, and then you do return 0.4 plus some marks 0, and now finally some marks n0. Now this is the base case. So in this case you just do a return 0 in this case. So over here you will simply do return 0. Now what will happen, this value over here will get substituted for this. How do I make this smaller? Okay. This value over here will get substituted here. So now this will become 0.0, which is nothing but 0.4. Then what will happen is this value gets substituted for this over here. So you get 0.4 here, which will be 2.9. Then this value goes here and you get 2.9 here. This will give you 4.0. Finally this value is returned over here to main. So sum marks 3 is 4, and since this number was 4 here, when you compare this with this you get that the total is correct, because 4 is equal to 4.0. So this is how the recursion works. Yep, that was all for this question. Okay, now on to the optional questions. So the first optional question was branching out, and you have to make a tree similar to this. Your tree will not look exactly like this because you don't know the angles which were used here. Even I don't remember what angles did I use. Do I have the code? Okay, I don't. So I don't remember. I will create a tree similar to this. Okay, so branching out .cpp. Okay. Alright. So you have to solve this using recursion. I have given a hint that you have your recursive function will take in the depth of the tree and create a tree of that particular depth. So one thing you should notice is that, okay, I'll copy this. Can I paste it here? Failed to fetch image. Okay. Let me try again. Alright. Will this work? Okay. Okay. So look at this part of the thing, and this is a tree on its own. Similarly, this is a tree on its own of depth n minus 1. Then this is a tree on its own of depth n minus 2, and this is a tree on its own of depth n minus 2. Okay, this is a tree of depth n minus 2, and this is a tree of depth n minus 2. This is the thing that you had to notice, that okay, how will you make this? So first you have your total here. You will go some distance ahead, you will turn to the left, and then this whole thing is just the tree of depth n minus 1. So you will just call the function recursively to create the tree of depth n minus 1, and then you will reach here again. You will turn right, you will go forward a little, you will turn left again, you will turn right, and then you create another tree of depth n minus 1, and then you will turn left and move backwards, so that you place your total at the base of the tree. This is the whole thing. This is everything that you had in the recursive function. And oh yeah, make sure that if n is 0, if n is 0, then you don't draw anything, and simply return. So I'll start with the code now. Okay, so you have simple cpp. Okay, let's call this function tree. So you have void tree with int depth. If depth equals 0, you simply return. Otherwise, okay, you go forward okay, you will actually need one more thing, which is called int x. I'll tell why this is required. Because you need the branches to be smaller than the um, tree. So you will go forward x, then you will turn left by let's say 30, and then you will call yourself with depth -1 and x by 2. Then you turn right 30, go forward x by 2, right 30, then 3 and depth -1 x by 2, and then left 30, forward minus x by 2, 3 into x by 2, and then return. And your int main, int depth, c and depth, and then oh my bad, you have to initialize total sim, and then call tree with depth and 100. Let's say your starting length is 100, and then you do, what was it, get click s plus plus branching out dot slash dot out. Okay, I input a 5, and where did this guy go? Okay, there it is. Why did it make it this way? Anyways, oops. Okay, just add left 90 here, and that should fix it. 5. Okay, 5 4 3. It's making a very sparse tree. Okay, let me use a bigger number, 10. Alright, I'll give it some time to finish. Okay, so what the code does is you go forward x, which is this trunk part over here, then you turn to the left by 30, and then you say that make a subtree. So this is a smaller tree of depth n-1 with the size of the trunk as x by 2. So you make the size of the trunk half as it was before. Okay, did I mess something up? Let's see. Let me make these 10 will be bad. Let me make this 50 first. A dot out. Why is it only creating one side? Okay, I guess I should not do this thing. If you go x and x, then I have to go 2 into x behind. Oh, 3x by 2 was right. My bad. 3. Okay, let's see what does this make. Nope. So this is right. This is not what I want. You go over here. Oh, okay, got it. I haven't forward x by 2. Nope, even that's fine. Okay, I will just make this smaller, maybe. Wow, okay. That should not have happened. Oh, alright. This will change. You go minus x minus 10. 5. Okay. This is much better. Let me create a bigger tree out of this. Oh, okay, wow. 7. Alright, good enough, I guess. Yep, that's as close as I'm going to get to this. Yeah, so the logic is the same. You make two recursive calls to tree, one for the left branch and one for the right branch, and you go some distance ahead over here. I have taken it as forward 10 for now. You could take this as 20 if you want. That will create a slightly different tree. And also you could change the trunk lengths for each and every one of them. That will change certain things as well. So yeah, that was it for this question. Okay. The last question now. Shit happens. Okay, so in this question, you will be given an integer n, and you have to give the corresponding column name. So 1 gives you A, 10 gives you J, 29 gives you AC, 52 gives you AZ, and so on. This will also be solved by recursion, and I have explained the algorithm that you have to use to solve it. So base case is simply that if n is 0, we simply return without printing anything at all. I'll start writing the code side by side so you get an idea of how to do this. CDP. Okay. Excellent column. Okay. Void and it will take an integer n. Okay. If n is equal to 0, you simply return. Otherwise, call the function excellent column recursively with the argument being n minus 1 by 26. So you do excellent column n minus 1 by 26 and then print out the correct number corresponding to n minus 1 by 26. So this is simply a plus n minus 1 percent 26. You typecast it to a character and then you do indent. Okay, this is the excellent column function. Then you have your int main, wherein you take an integer n and then you call the function. This will print the right answer. I will explain why these numbers are taken. One sec. Sheet happens. Let's try 29. Oops. Okay, I don't have to do end L here. I'll do end L at the end. 29 AC 52 AZ 5103 GNG. Okay, let me try 30 502 1165. Okay, alright. So think of it this way: you have solved questions which involved converting a decimal number to binary and converting a decimal number to hexadecimal. Think of it similarly. Think of it that you have 26 numbers which are A to Z, and you are trying to convert this number into a number system which has 26 numbers, but the numbers start from A and they go to Z. So A, B, C, D, E, F, G, those are the numbers that you have. So this is that problem exactly. Okay, so you treat it as a 26 base system of numbers, and usually the base system of numbers, they start from 0, right? They start from 0, but over here you are starting from 1. So 1 is represented by A, and then 2 is represented by B, and so on. That is the reason why you require an n minus 1 over here to shift all these numbers by 1, so that you map 1 to 0 and 2 to 1 and so on and so on. That is the reason why this n minus 1 by 26 and n minus 1% 26 is needed. Other than that, this just extracts the last digit in the 26 base system, and this is the rest of the number. So this removes the last digit in the 26 base system. This is how you can understand what is going on in this code. So what I do is, let's say I had the column name as AAA. So if I do this n minus 1% 26, I will get this A from here, and I will print it out at the last. So after these two A's are printed, then I will print this A. That's why this print statement is after the recursive call, and these two A's will be passed on to this recursive function, and these two A's will be printed recursively from inside, and then when you return back over here, that's when this last A will be printed, and then it's done. Think of it in this way. I guess that is one way of thinking of it. Yeah, just try to think over it more and you get it. It is not that complicated once you get it, but when you're trying to understand for the first time, it will be slightly confusing. Yep, that's all. That was lab 5, everyone. Thank you.